My name is Tom Brown. I'm on the development team in Redlands. This is our demo theater session on tracing. So I'm going to try to show some basic examples. With some of your input and questions, we can kind of jump around as we go. But I just wanted to show some of the fundamentals of the tracing framework and configuration via Pro, right? How many of you so far have been just working specifically in Pro with the utility network? Are you, any of you venturing outwards towards building some of the web apps in runtime, working directly with the endpoints? Okay, that's really valuable. So touch upon some of those examples. So let's just start with some of the basics, right? So here I am zoomed into an area, and this is electric. And I won't be electric-centric all day. I'm going to jump over to some gas data as well in a little bit for a pressure trace and isolation trace. But here, let's just start with our typical fine subnetworks, right? So if I want to go ahead and trace a subnetwork, which is a circuit in electric, right? So you have to remember, Pro and what we provide with the utility network is agnostic to the specific domains or industries, right? We had to build a framework that would be applicable across all domain industries, be it wastewater, stormwater, electric, gas, and so forth. So we couldn't come up with tools or commands that were specific to any user's expectation of how they would interact with the software, right? Doing a pressure trace, for example, or a circuit trace in electric. So that's why we have this terminology called subnetwork. And it's the concept for managing these sub-portions of your entire domain network and your utility network. So that was an easy way to do that quick trace of that circuit 107, returning over 6,000 features. And that's going to include all the containers and all the structures as well. Now, let's see if we actually wanted to do that by calling the subnetwork tool in the trace gallery, right? So as we all know, it brings up our geoprocessing tool, which is our trace tool. Now, right away, we know what utility network we're working with. So in our Pro maps, we typically work with a single utility network. Now, a quick question to the audience. Do any of you envision needing or having a solid business use case of wanting to have multiple utility networks in the same map? Okay, so afterwards, talk to Larry Young. I'll throw it all on Larry. But we'd really like to hear your input and the use case and the workflows of why you're doing that. And try to understand that, because right now, our user experience in Pro is constrained to working with one utility network, right? And you might recognize why is because our ribbon is based on a single utility network. We haven't taken it as far as we did in ArcMap, where you would choose the active geometric network, and the ribbon would then know to work with that specific network. Now, in our backlogs, right, we need to know how important it is to support that requirement. All right, so here we are going to do the subnetwork trace, right? And again, we can choose what domain network, and I'm, in this case, going to work with distribution, and as well choose which tier in that domain network. Typically for electric, our tiers might be based upon our voltage levels of what we'd want to represent. So here in my case, we're going to choose medium voltage. Now, one of the things about our trace in our domain networks at the tier level is you as the administrator configure what the trace configuration is. So that allows us then on this specific tool, as well as doing upstream or downstream, we can pull in that trace configuration automatically for the user and then execute. So again, if we were to actually expand these options and look at traversability, we can see what it preloaded for us. And in my case, I'm simply specifying that the device status, when finding a device where the device status is a network attribute, is open, becomes a terminator or a barrier for the trace. As well, in this model, I'm showing that I also want to stop a trace if I ever come to a feature that's abandoned. So in this model, I can preserve features that go through a life cycle from pre-planning to as-built to finally abandoned, and keep them in the model, but not specifically trace across those features. But I still have connectivity, for example. All right, so again, if we were to run this trace, it would do exactly what we'd expect, right? Gives us the same result, 6249. Or it just may fail. Why did it fail? No valid starting locations found. That's not good. All right, run that again. Always give it 2 tries, the old college effort. All right, while that's running, no, it's still failing. Ugh. So let's talk about some of these options real quick. Oh, thank you. I didn't have a starting point. That's always perfect to have input from the audience. Because I didn't have a trace location, nor had I specified a subnetwork name, there was nothing to trace. Now that just showed me we need a better error message to clarify that. All right, so choosing subnetwork 107, it would run, but before I hit that again, right, I have the options to include containers. Those are any of the polygon features, maybe our structure boundary feature, like I have the substation, or it could be the assembly features that are the containers of multiple devices at a given location. The include structure line junction container content. Often I've seen questions where people aren't completely understanding this, and maybe we need to improve on the documentation. But we added this option specifically when you're often tracing the structure network itself. For example, I'm tracing the ducts themselves. And as I go from manhole to manhole through the duct network, I want to also return what are the features contained in those structures. So as we do that trace, we know all the linear features, and we know what's inside the manholes or the vaults and handholds and so forth. Include structures, those are all our structural attachment features, like our poles or our towers. Barrier features. Now, this is an important one to understand, because when I do that trace, and I said device status is equal to open, right? If I don't include that feature as a barrier feature in the result, of course it wouldn't include the switch that was open, or the fuse, or maybe the transformer that's blown, as in the result set, or a valve if you're tracing a pressure zone. That becomes important to understand given what type of features you want back in your reporting and your modeling. Now the validate consistency response, or option, what we're doing here is actually we perform the trace, and we take the result set of all the features in the trace, and we intersect that with all the existing dirty area features. Because remember, we can perform a trace or an analytic anytime that the topology is enabled, right? So if I've done some editing which creates the dirty area features, or I've edited an existing feature that's part of the topology. For example, I could go to a fuse and I could change that network attribute device status from open to close or vice versa, which creates the dirty area, but the topology itself has not been updated until you do that validate network topology. Therefore, we need a mechanism for you to be able to know how much do I trust those trace results? Because it's a dynamic system. As users are editing, dirty areas are being created, validations are cleaning up those and updating the topology. So by including this option, it will tell you, return you back a warning that says, hey, for the result of that trace, a dirty area was detected, right? You may need then to validate, because you could end up getting a completely different trace result. Now this is a new option that we've added here, because we realized there are times when we're doing traces and the starting point itself meets the barrier condition, right? So we said, oh wow, there could be analytic examples where we actually do want to start from that location, go in a specific upstream or downstream direction, whereas before we would immediately stop the trace starting at that trace location. Again, because it's a framework, we're trying to expose all these options given the type of analytics that need to be performed. All right, so another thing I wanted to show, and I'm going to come in here. How many of you have started to play with Fiddler? to understand how, right? A lot of you, right? So what I'm going to do real quick is I'm just going to highlight that active session. And when I come in here, let's get rid of that. All right, so now let's actually run this trace. Now that we've correctly specified the subnetwork, since I don't have a trace location, we can actually see what's going on here, and we can find the trace call itself. So why this becomes important, especially for developers, is, hey, what are all the arguments to the actual REST endpoint? Because I may not always be working in Pro. I want to start working directly with these REST endpoints because I'm writing my own web application. I'm writing my own back office process that's just going to call that directly. So what I've done here is by using Fiddler, I could have run any type of trace, and I can capture that actual REST endpoint call and see all the arguments. Right, so here you can see what's happening. We're performing this with a JSON request. We're hitting the default version. The session ID, that's going to be specific to your session in Pro, or if you need some locking going on behind the transaction model. I'm not going to get into detail. Because we're versioned, we have to work with specific moments. And then the trace type, right? Subnetwork, but what's really important here is this trace configuration. So if we go ahead and copy that. Now, let's just go over to the actual REST endpoint. So here I'm in Server Manager looking at my services. I've got the utility network. I can go to, hit Advanced, Proceed. Hopefully it's going to allow me to go. Yep, I got to kill Fiddler. Get back out of there. All right. So now we've gone to the utility network service itself, right? It's just an SOE off of the map service for when we published, right? When we published with the utility network layer, we automatically get the utility network service. So if we go to the trace endpoint, you can see those exact same arguments that you saw before from Fiddler. Now, because some of these arguments are optional, like a version, if it's not provided, we're always going to trace the default version. So if I'm going to enter a subnetwork, trace locations, I don't have any. So bracket, bracket, and there's the trace configuration that I copied. That has all the specific arguments of how I'm going to perform the trace. So back on the GP tool, right, you saw we have all the traversability arguments, we have the filter arguments, the functions and outputs and so forth. So of course now if we run this here, you can see it's going off, executing. We saw that last one took about 3.5 seconds, and there are all our trace results. Right? So as a user hitting the endpoints directly, you can get back the object IDs of the features in that result set. Then you would turn around and make a call to your feature service or map service to actually pull those features back in order to render the result set. So you need to keep that option and understanding of the framework for all your developers to build out these applications. All right, another example. Of course, talking about different functions and availability. Let's go ahead and clear our result sets. Here, the functions, we have all the different ways to be able to support a function. So if I wanted to add the attribute, we're going to go with a shape length. If I go ahead and run that, you're going to see it's the same trace. And if I look at the details as this finishes, it's going to sum up the shape length of every feature. And then you can see now there's the total length in the units of the feature data set. So over 106,000 feet of distribution line in medium voltage. Of course, you can take that further and start to specify a filter by category. Filter operator is equal to a specific value. And in my case, what I've done is I've added categories at the asset group, asset type level to specify if the line is overhead or underground, right? So now if I rerun this, I can get a quick sum of the count of the overhead lines. So again, this is where categories become very important in your data modeling of how they can be leveraged during the analytics. Let's get that, get back to the view details. I should get now an updated value. Now you can see just the overhead lines, the total sum is just over 5,000 feet of overhead lines. So a lot of underground in this area. All right, another type of trace real quick. If we go ahead and look at an upstream trace. Now, one of the things I've configured in MAP, which is extremely helpful, are the locate tools. So I've configured on many of the layers, I've set locate filters to be able to query based on values, like maybe a work order ID, a global ID, an asset ID, a structure ID, and so forth. So it's very easy then to find these, and I've run this earlier, where I found a specific service point. Now I've got it selected right here. And if I go to my trace locations, I can load that. And now back to my upstream trace. So now I have a starting point for my trace location. Again, I specify which domain network I'm working with, electric distribution. We're going to say medium voltage. And just keep this clear, we'll turn off the containers and structures. We won't even validate because I know I don't have any dirty areas. Even just doing that validation may save us 1/10 of a second, right? Doing that intersection of the result set, because this is all taking place on the server, is just a real quick query against the dirty areas table. So if I come over and pan into my substation, I display my content, I can zoom in and see where this trace actually terminates. Typical upstream trace, it stopped at our subnetwork controllers, which are the circuit breakers in the substation. Here they have 2 of them for redundancy. But let's actually now go one more step further, right? We're going to trace across tiers, where I'm going to say I know I'm starting in the medium voltage, and I actually want to trace up into the distribution substation tier. So by just adding that same option, repeat the trace, now we can see where it goes through the substation itself at that 12 kV voltage level to see it stops at that specific step-down transformer. Now, if we zoom a little bit, just to highlight one of the backlog items that we need to work with the pro team is, we came in on these 2 specific circuit breakers that are selected, right? Recall, we came in, there's our distribution line coming in, we came to the circuit breakers, and they're connected to that bus bar. And then from the bus bar itself, it came down to that connection point, and it looped off, and it comes around how it loops all the way back. What we need to start doing is showing partial edge results, right? So we only see the portion of the edge of that entire feature that is part of the result set. Very important for electric as well as gas when we do start doing isolation traces or understanding a path trace through a subset of a feature. So we're working on that, hopefully for the 2.4 release. All right. Another thing is customizing the gallery, right? We put a lot of work into this. Out of the box, we provide these collection of specific trace types, right? We see connected subnetwork controllers upstream. But not all users would necessarily need to or want to interact with all these specific trace types. So we can come into the gallery itself and customize what's available. I'm going to reset this to default. So you can see those are all the normal trace types we provide. So as a user, I don't know what a subnetwork trace type is, right? I'm going to remove that, and I'm going to add a specific model that I've built, which is the circuit trace. Go ahead and click that. Now you can see that's added to the gallery as a trace option. So as a user, when I want to actually come to the circuit to do a circuit trace, I would just simply click on that tool. Now the geoprocessing tool only presents me with the option to say, what specific circuit do I need to trace? And it takes care of all the other arguments that end user simply doesn't want to interact with. Now, again, that's going to return our same 6,000 features. That time we got a warning that there was a trace location starting point already set. It was intentionally ignored because I'm doing the trace by name. So that was an expected warning. We can zoom out to that result. Now, let's actually look at that circuit trace, right? It was just a model, and if we come in here and go ahead and edit, come on, it's going to the extent of that trace. There's that entire circuit 107. We go ahead and open this model, right? It's a very simple model, just taking the trace tool itself as input, passing in these options to include containers or not, right? I can just open that up. There's my same checkbox that we saw before, right? Very basic ways to build these models. And of course, you can make these models very advanced. If I wanted to do traces where I had different life cycle attributes where I can dynamically change those. All right, now let's jump over and look at one of the new trace types that we introduced at 2.3 is an isolation trace. Here we are in a gas network, and we're looking at a data set in Wisconsin. And all I'm doing here is symbolizing based on the pressure level of these pipes at this scale. Of course, the darker the blue, the higher level pressure, and the thinner the line, the lower pressure. So when we zoom in, we can see. Now, one of the other things that's pretty cool is using Arcade to dynamically change my symbology as I move at different scale levels. So now we're actually looking at the material type of the pipe, where the black lines represent steel and the green lines represent plastic. So let's zoom back out just for a second here, and let's go ahead and add a trace location. We're going to add a starting point, get rid of that guy. And we're going to stick it right there. And we come to geoprocessing, back to our trace. Choose our isolation trace. Again, the domain network is our gas, and we're specifically tracing on our distribution pressure. For now, we can get rid of the containers and the structures. And then we're going to specify a filter. Now, the filter type I'm going to use is a category, a specific value of type isolating. So I've assigned that to the different features in asset group and asset types to know what are my isolating devices. So here I go ahead and run this, and we're going to see the results come back with 2 features. Now, why did it only return 2 features? Well, what it is actually returning are the devices, the valves, which can isolate and protect this area. Right? So now I can go visit those. There could be also another network attribute on those valves if it's accessible or not. Right? As you do your valve inspections, you know if it's paved over, how easily it is accessible to your field operations team. Is it a candidate to be used to close this? Now, that kind of helps, but let's rerun this, but include the option here to include the isolated features so we can actually see a better visual representation of all the features that would be isolated when we close those 2 individual valves. And you can see it's a pretty large area, returning 229 features here. So if we were to just isolate based on those valves, we would likely also lose gas to many of our customers. So let's add an additional filter barrier that says, let's base again on a category, a specific value of, oh, no, I don't want to do that. I want to use a network attribute, sorry. Pipe is pinchable, equal to a specific value being true. Essentially now we're saying when we rerun this trace, hey, when we fan out, instead, can we locate any pipes that are pinchable based on the material type of plastic? So now the results, 78 features, and as expected, we were able to pinch at this first plastic pipe. So we've isolated less of our customers. So a demo theater of less than a half hour barely scratches the surface of all these options in this framework. So the big takeaway here is you've got a lot of flexibility to configure these traces, where before, with the geometric network, you really had to be a sharp developer and use our forward star cursor, and with all the complex options there of how you walked each individual element. We turn that model into building a framework so we can configure traces, and we can call those directly. Now, our long-term roadmap is, once we start having the utility network in mobile geodatabases where we can take them offline and have the topology, in that runtime API, we are going to expose a forward star cursor so you can even start writing far more advanced analytics like you have in the past. Right? We still have to have that requirement. All right, I've just got a couple of minutes for questions because Rick Anderson's going to come up here and do a diagram demo theater at 9:30.
Do you know if REST.js has covered any of these yet?
I'm sorry, REST?
REST.js, do you know if they've covered any of these?
Oh, in our JavaScript and API. The question is, when will our JavaScript REST API have the options to start calling the endpoint directly? That is also on our near-term roadmap, because we know we want to start building those. But it hasn't been a top priority because so many of you are so sharp, you can just call directly out to these REST endpoints yourselves. So it's had a lower priority. You guys are too quiet for a morning session. Come on. One more question. Anything. All right. Got one hand. Can I show us, what was that? Oh, the traversability on this one. It was a very simple, for the pressure networks, it's simply saying for any valve which is closed, stop the trace as the barrier, right? So it's going to fan out and automatically stop at closed devices. All right, I appreciate your time. Rick's going to do a half-hour demo session on diagrams and configuration. This afternoon at 1 o'clock in one of these rooms over here, we're doing the advanced utility network session. So hopefully see you then. Thank you.